Okay, now we have three functions, two that are linear, one that is radical. Okay, for the linear functions we have y is equal to 0, x is equal to 6, and we have that y is equal to the square root of x. And we want to determine the volume of the solid generated about the x-axis. And in terms of the two-dimensional construct, okay, we have that y is equal to the square root of x, and y is equal to 0 is going to be the x-axis. And we have for, again, the boundary, vertical boundary, we have x is equal to 6, and for our contact points, okay, we have at the corners we have the origin 6 0, and also we have the remaining point of intersection between x equals 6 and y is equal to the square root of x, which again we have x equal to 6 and y is going to be at the square root of 6, and we're looking at determining the volume of the solid generated about the x-axis. And you can think of, once again, an equal half mirroring on the other side of the x-axis. And since we have continuous contact with the x-axis, and since we have revolution about the x-axis, again we have solid that is going to be where its volume can be determined by using the method of disks. Okay, so we have no hollowing out, no spacing away from the x-axis, and so we can rely upon the method of disks. Okay, and now we have for the radius, in this particular case, that is going to be the height of the two-dimensional section, and that is going to be at the square root of x. So with the disk, once again, the radius is going to be equal to the square root of x. And with the determination of the volume, which we can very quickly determine, we have going from x is equal to 0 to x is equal to 6. And again, with disks, we're thinking along the lines of pi r squared. So you're looking at pi times the square of the square root of x. And so for what we have and what ensues, okay, square root of x squared becomes x. So you have pi times x dx. And so for what we're going to have at this juncture, we can now take the power rule of integration. So we have pi times x squared over 2 as x goes from 0 to 6. Okay, and so for what we're going to have in this outcome is that for this particular solid, almost like a helmet or a bullet in formation, you have 6 squared is 18 divided by, let me rephrase that, 6 squared is 36 divided by 2, so that is going to be 18 multiplied by pi. So we have for the volume of the solid generated about the x-axis is going to have an exact value of 18 pi.